In mathematics, differentiation is a fundamental concept in calculus that helps us understand how things change. It measures the rate of change and is widely used in science, engineering, and economics. The derivative of a function represents the slope of the tangent line at any given point. This tells us how fast a quantity is changing, whether it's the speed of a moving car, the growth of a population, or even the shape of a roller coaster. Differentiation helps us identify key points in a function, such as maximum and minimum values, which are essential in optimization problems. It also helps us determine rates of change such as velocity and acceleration in physics. Throughout this discussion, we will explore the fundamental rules of differentiation, apply them to real-world problems, and analyze graphs using derivatives. Let's dive into the world of differentiation and see how it shapes the way we understand change.
We're going to solve a differentiation problem for our discussion today.
So, the first question is fx equal to x squared plus 3x plus 4. So, we need to find the stationary points by differentiating and equating to 0.
Right, let's recall. Stationary points occur where the derivative is 0.
Good point. Anun, can you take us through the differentiation?
Yeah, we need to find the stationary points and determine their nature. The next step that we can do is f prime x is equal to 2x plus 3. Why? Because the x square just now that I said, the power, the square pergi depan, which is 2, and then 2 power, always remember kalau differentiation dah always minus 1 itu power dah. So that's why it becomes 2x. And then why 3x? Because the x ada power 1, and then bila 1 tolak 1 dia jadi kosong, jadi 2x dia jadi kosong, so tinggallah 3. The next step that we can do is the f prime x jadi 0 sebab kita mau cari value of x, so 0 is equal to 2x plus 3. And then the next step, take the 2x and then power p sebelah dia jadi negative 2x equals to 3. Jadi x is equal to negative 3 over 2.
Great! Now, let's substitute it back into the original function to find y.
Step 2. Find the value of y when x equal to negative 3 over 2, fx equal to negative 3 over 2 square plus 3 multiple negative 3 over 2 plus 4. So, y is 7 over 4.
Step 3. State the stationary point. Therefore, the stationary point is, for coordinate x is negative 3 over 2, while y is 7 over 4. Now, we check if it's a minimum or maximum.
Step 4. Determine the nature. So, dy over dx is equals to 2x plus 3, which is that was our first order. Then, the next step that we can do is find the second order, which is d square y over dx square, which is we got 2 because when we differentiate 2x plus 3 kita dapat 2, so is equals to 0. 2 is more than 0, so which makes that this is minimum point.
First, we create a table of values by substituting different values of x into the function of fx. The function decreases until x equals to negative 3 over 2, forming in bracket negative 3 over 2 and 7 over 4 as the minimum point. Then, by plotting the graph, we plot the calculated points starting from the first column, which is in bracket negative 3 and 4. And next, in bracket negative 2, 2, then move on to in bracket negative 3 over 2 and 7 over 4, in bracket negative 1, 2, and next in bracket 0 and 4, and lastly in bracket 1, 8. After that, we draw a smooth curve through these points. Since x squared has a positive coefficient, the parabola opens upward. Last but not least, finalizing the graph, we can see where minimum point is at, in bracket negative 3 over 2 and 7 over 4. The graph is symmetrical around x equals to negative over 2, and the function extends infinitely in both directions.
Awesome! One down, now let's move on to the next equation.
Next, y equal to 4x cubed plus 3x squared minus 6x. We differentiate dy dx equal to 12x squared plus 6x minus 6. Next, set it to 0. 0 equal to 12x squared plus 6x minus x. x1 equal to 1 over 2 while x2 equal to negative 1.
Step 2, let's find the value of y. When x1 equals to 1 over 2, y equals to 4 in the bracket of 1 over 2 cube plus 3 in the bracket of 1 over 2 square minus 6 in the bracket of 1 over 2, which equals to negative 7 over 4. When x2 equals to negative 1, y equals to 4 in the bracket of negative 1 cube plus 3 in the bracket of negative 1 square minus 6 in the bracket of negative 1, which equals to 5.
The next step is state the stationary point. There are 2 points. So the first point, x equals to 1 over 2 and y equals to negative 7 over 4. And for the second point, for x equals to negative 1 and y is equals to 5.
Step 4. Determine the nature. So dy over dx is equal to 12x squared plus 6x minus 6. That is our first order. Our second order is d squared y over dx squared is equal to 24x plus 6. Why? Because power 12x squared itu 12 darab 2. Sebab tu power kan DP depan. So 12 darab 2 dapat 24. And then to x square tu 2 tolak 1 dia jadi 1, which is tinggallah 24x. Then yang 6x tu kan to x tu kan kuasa 1 je. So 1 darab 6 dapat 6. And then 1 tolak 1 jadi kosong. Jadi to x hilang. Jadi kita punya second order 24x plus 6. So when x is equal to 1 over 2, d square y over dx square, kita kasih masuk yang tadi tu equation 24x plus 6, kita kasih masuk tu 1 over 2 bagi x. So 24 kurungan 1 over 2 plus 6, we're gonna get 18, which makes that is our minimum point because 18 is more than 0. When x is equal to negative 1, d square y over dx square is equals to 24 kurungan negatif 1 plus 6. Kenapa? Sebab kita mau tahu berapa value x, apa dia punya point kan. So 24 kurungan negatif 1 tambah 6, kita dapat negatif 18, which is maximum point sebab dia less than 0.
To summarize this equation, point for coordinate x 1 over 2 and y equals to negative 7 over 4 is minimum point. And for point coordinate x equals to negative 1 and y equals to 5 is maximum point.
After determining the stationary points and their nature, we proceed with constructing the table of values and plotting the graph of the function y equals to 4x cubed plus 3x squared minus 6x. Table of values. The table provides values of y for different values of x, including negative and positive values to ensure a smooth curve representation. The calculations involve substituting each x value into the given function to obtain corresponding y values. For instance, when x is equal to negative 2, y is equal to negative 8. When x is equal to negative 1, y is equal to 5. When x is equal to negative 1 over 2, y is equal to negative 7 over 4. And then can continue. These values help in accurately sketching the curve by identifying key points. Sketching the graph. Using the table values, we plot each point on the graph. The curve is drawn smoothly, ensuring it passes through the stationary points. The maximum point at negative 1, 5, where the curve reaches a peak. The minimum point at 1 over 2, negative 7 over 4, where the curve reaches a valley.
In conclusion, we successfully identified the stationary points of both function and classify their nature using the second derivative test. By sketching the graph, we visualize how the function behave at these points. Differentiation plays a crucial role in engineering application. In structural engineering, it helps analyze load distribution and optimize material usage in construction. In mechanical engineering, it is used to study velocity and acceleration in motion analysis. In electrical engineering, differentiation is essential for understanding signal processing and control system. By mastering differentiation techniques, engineers can design more efficient structure, optimize system performance, and solve real-world problems effectively. Thank you for your attention.